Something has seriously been bothering me for the past couple of months. Back in December, I was surfing the web, as one does, when I came across a video of somebody making a programming language. And I thought, oh, that's cool. Programming languages are cool. It's always cool to make one. So I'm watching the video, and, you know, it's a programming language. It's got a Python interpreter. It's got, you know, whatever. It's Turing complete. But what surprised me, this entire thing is made by some kid. Now, I don't consider myself a bad programmer, but when I was around this kid's age, these are the kinds of projects I was making. And why the heck am I crying myself to sleep every night over CS assignments? Like, they have me out here programming in Lisp. You're not allowed to do that to prisoners. Why are you, I guess since we're an academic institution, you're allowed to do that to us? So I decided, you know what, I can make a programming language too, watch me. You might be saying, Josh, isn't it a little insecure and petty to make an entire programming language just because you don't want to be outdone by some kid? Well, counterpoint to that, 11 empty cans of Canada Dry. I already recycled the 12. Now, despite my irritation at its very existence, D++ is a pretty cool project. It's kind of similar to BASIC or assembly languages in that it's a set of instructions that are put into a list and then executed one by one as a program. And somebody actually demonstrated the Turing completeness of D++ by implementing Rule 110, which is pretty cool. It's a pretty cool project, and you'd have to be pretty annoying to try and pick it apart, especially when it's clearly not meant to be something professional. But being annoying has never stopped me before, so I decided to learn how to make a programming language of my own. There's a good series of tutorials on YouTube by a guy named Tyler Lacerdy about how to make a programming language, but they're all in TypeScript, and I just couldn't stand that, so I decided I'll follow along, I'll do all the work, but I'm gonna write it in C# instead. And actually, I have the source here. I have the source here of the project. So yeah, you can take a look at that. Oh, hey there. Come on in. Yeah, come on in. This is the front end. We determine what things mean here. This here is the lexer. It takes in the source code and then it chops it up into tokens that the rest of the front end can actually use. You can kind of think of him as like a really good butcher. Like, we take in a whole cow, and then he determines what the good cuts are, and then sends off the undesirable bits to a factory to be made into delicious glue. And over here is the parser. So the parser takes in the list of tokens from the lexer, and it says, oh, they're in this order, they fit this pattern, whatever. It means this, and then it constructs a big tree of basically meanings from these tokens, and then it sends the tree that represents the meaning of the whole program. You can kind of think of the parser as that one art student roommate you had who went to the butcher's to get cuts of meat and then built a tree out of them. And here's the runtime. It takes in the meat tree from the front end, and then it runs the program. It reads, writes values, does mathematics, the works. Very cool stuff, I assure you. So what is this Metsu language? What does it do? Well, Metsu is an imperative language that basically means that it gets interpreted from top to bottom, unless your code's in a function definition or something. It uses C-style syntax, basically means each statement ended with a semicolon, and it uses curly braces for code blocks. You might be saying, Josh, that sounds very standard, but not very super interesting. Of course it does. I haven't mentioned the interesting stuff yet. Now, when it comes to integer constants, most languages give you a couple of options. They give you your base 10, they give you your base 16, sometimes they'll even give you base 2 or even base 8. My language, we support all of those as integral constants, but we also provide support for base 4, base 32, and even the very useful hexatridecimal base 36 integral constants. Language also has some things that some programmers actually really like functions as first-class objects, which means that a function can be assigned to a variable, it can be passed into other functions as parameters, and they can be returned from other functions too. Variables are also immutable by default, so if you declare a variable with a value, then you can't change its value to another value unless you add the mutable keyword in front of it. But that's only default. The people who like that are smelly nerds. So I provided an alternative. If you put #mutable at the top of your file, all your variables will be mutable by default. And your constants? You'll have to add the constant keyword to make them constant and immutable. There's also the 3 standard modules that I mentioned earlier. You can call those. They organize all sorts of native code that's useful. And now, with all that knowledge, we can finally write a program.